Next topic is steam flow velocity. Okay, so in nozzle we need to find, so what is the exit velocity? Okay, so this we have already derived when we derived the steady flow energy equation for nozzle in basic thermodynamics. Okay, let us do it again. Okay, small derivation. So here we can see the nozzle. Okay, so convergent nozzle. So here the initial conditions are taken it as 1 and the final conditions are taken it as 2. Okay, so here, so P is pressure, V bar is velocity, and V1 or V is specific volume. So 1 is for entry and 2 is for exit. So consider a unit mass of steam flowing through a convergent nozzle as shown in figure. Okay, to derive this, obtain the exit velocity, we need to consider steady flow energy equation. We know that steady flow energy equation is given by h1 plus z1g plus v1 bar square by 2 plus q is equal to h2 plus z2g plus v2 bar square by 2 plus w. So call it as equation number 1. We know that in nozzle there is no external work output, so W will be equal to 0, and nozzle is insulated, so there is no heat transfer, so Q will be equal to 0, and nozzle is placed horizontal, therefore Z1 will be equal to Z2. So above equation becomes, if we substitute all, so Z1 and Z2 get cancelled, Q1 is 0 and W is equal to 0. So finally we get H1 plus V1 bar square by 2 is equal to H2 plus V2 bar square by 2. Okay, now by taking this V2 bar square by 2 left hand side and sending this complete term to right hand side, we get H1 minus H2 plus V1 bar square by 2. Now cross multiplying, V2 bar square is equal to 2 times of H1 minus H2 plus V1 bar square. Okay, finally, so V2 bar is equal to square root of 2 into H1 minus H2 plus V1 bar square. Okay, so this is the equation to find the exit velocity in a nozzle. So call it as equation number 2. Okay, so in nozzle, if we compare to exit velocity, inlet velocity is negligible. So neglecting that V1 bar, we get the equation V2 bar is equal to square root of 2 into H1 minus H2. Okay, so this is the exit velocity if we neglect inlet velocity. So now here H is in kilojoule per kg Kelvin, sorry kg, no Kelvin, and we need to convert that to joule per kg. So what we need to do? So multiply by 1000. So now finally the equation becomes V2 bar is equal to root of 2000 into H1 minus H2, that gives in meter per second. Okay, practically, so this is theoretical velocity. Practically there are some losses in the nozzle, that is in between 10 to 15%. So to take this into consideration, we need to introduce a factor, that is friction loss factor, represented by K. Okay, so now the above equation becomes V2 bar is equal to root of 2000 K into H1 minus H2. Okay, this is if we neglect inlet velocity. If we consider inlet velocity also, the equation becomes V2 bar is equal to square root of 2000 K H1 minus H2 plus V1 bar square. Okay, so next let us see the one of the important derivation in this module is condition for maximum discharge or critical pressure ratio. In both the names they can ask you to derive the equation. So to derive this, we know that nozzles are always designed for maximum discharge. Okay, so to obtain this discharge or maximum discharge, so first we need to consider mass flow rate equation. We know this mass flow rate, that is represented by the m, is given by area into velocity divided by specific volume. So here we have taken the exit condition, since the mass flow rate between entry and exit remains same. Okay, so here m is given by A2 multiplied by V2 bar divided by V2, that is specific volume. Call it as equation number 1. To find V2 bar and V2, we know that in nozzle, gain in kinetic energy of steam will be equal to drop in enthalpy. So what happens in nozzle is some enthalpy drop occurs between entry and exit. That energy is used to convert in or increase velocity or kinetic energy of the steam. Okay, or it is also taken it as gain in kinetic energy of steam will be equal to work done during Rankine cycle. So gain in kinetic energy is given by V2 bar square by 2 will be equal to work done during Rankine cycle is given by N by N minus 1 into P1 V1 minus P2 V2. So this we have already discussed. Okay, now V2 bar square by 2 is equal to N by N minus 1, taking common P1 V1 in this. Okay, if I take P1 V1 common, so this becomes 1 minus P2 V2 divided by P1 V1. Call it as equation number 2. Okay, so now in the nozzle, the steam flowing through the nozzle, it follows perfect gas equation, that is PV power n is equal to constant. So what is n? N is an expansion index or index of expansion. So therefore P1 V1 to the power of n is equal to P2 V2 to the power of n. Okay, so above equation can be written as like, so V2 by V1 is equal to P1 by P2 whole to the power of 1 by n. So call it as equation number 3. Okay, now substituting equation 3 in 2. If we substitute equation 3 in 2, we get V2 bar square by 2 is equal to N by N minus 1 P1 V1 into 1 minus P2 by P1 and into P1 by P2 whole to the power of 1 by n. In place of V2 by V1, we can substitute P1 by P2 whole to the power of 1 by n. Next, V2 bar square by 2 is equal to N by N minus 1 P1 V1 into 1 minus P2 by P1 into P2 by P1 whole to the power of minus 1 by n. What happens here? If we take reciprocal, so the index 1 by n becomes minus 1 by n. Okay, next, now V2 bar square by 2 is equal to N by N minus 1 P1 V1 into 1 minus P2 by P1 whole to the power of n minus 1 by n. So how it means, here P2 by P1 index is 1, this is P2 by P1 index is minus 1 by n. 1 minus 1 by n, take reciprocal n, so now you will get n minus 1 by n. Now V2 will be equal to square root of 2 into n by n minus 1 P1 V1 into 1 minus P2 by P1 whole to the power of n minus 1 by n. So this is called it as equation number 4. Okay, now from equation 3 we have V2 is equal to V1 into P1 by P2 whole to the power of 1 by n. So equation 3 we are having like V2 by V1 is equal to P1 by P2 whole to the power of 1 by n. So cross multiply that V1, so we will get V2 as this one, call it as equation number 5. Now substituting equation 4 and 5 in 1. So substitute equation 4 and 5 in 1, we get m is equal to A2 into, so what is V2 bar? V2 bar is root of 2 into n by n minus 1 P1 V1 into 1 minus P2 by P1 whole to the power of n minus 1 by n divided by V1 into P1 by P2 whole to the power of 1 by n. This value is this one, V2 value. Okay, now further simplifying this, we will get m is equal to A2 by V1 into P2 by P1 whole to the power of 1 by n. You can see here, this is P1 by P2. If you take it to numerator, this becomes P2 by P1. Okay, into root of 2 into n by n minus 1 P1 V1 into 1 minus P2 by P1 whole to the power of n minus 1 by n. So here bracket is there, so that is missed. We'll try that bracket. Next, a2 by a1, sorry, v1 root of 2 into taking this p2 by p1 1 by 1 into root. Okay, so now a2 by v1 root of 2 into n by n minus 1 p1 v1 into p2 by p1 whole to the power of 2 by n. So 1 by n becomes 2 by n because you are taking this 2 inside the root. So this becomes 2 by n into 1 minus p2 by p1 whole to the power of n minus 1 by n. Next, a2 by v1 into root of 2 into n minus n by 1 p1 v1, multiply this to this inside the bracket. Now you will get p2 by p1 whole to the power of 2 by n minus p2 by p1 whole to the power of 2 by n into p2 by p1 whole to the power of n minus 1 by n. So now further simplifying this, okay, so here you can see the index 2 by n plus n minus 1 by n. If you simplify that, so m is equal to a2 v1 square root of 2 into n by n minus 1 p1 v1 into p2 by p1 whole to the power of 2 by n minus p2 by p1 whole to the power of n plus 1 by n. If you simplify this, you will get n plus 1 by n. Okay, so call it as equation number 6. So, and this equation gives the discharge of steam through a convergent nozzle. So this gives the discharge of steam through a convergent nozzle. You can see here, if we know area, that is A2, V1 and N, if we know these three terms, or we can call these three as constant, okay, and so what happens? So this m will be a function of what? P2 by P1. Okay, so that is called as pressure ratio. Okay, so if we know these three terms P1, N and V1, so then this will be the function of only P2 by P1. Okay, that is pressure ratio. Now for maximum discharge, if you want maximum discharge, we need to differentiate this equation with respect to pressure ratio. Okay, that we will see now. So the maximum discharge is obtained by differentiating the above equation, that is dm by d into p2 by p1 is equal to 0. So here you can see in that m equation I have considered only the pressure ratio, okay, because all other terms are p1, v1 and n are constants. So now, so if we differentiate this one, okay, let us do the differentiation one by one. So what is differentiation of p2 by p1 whole to the power of 2 by n is 2 by n p2 by p1 whole to the power of 2 by n minus 1. Okay, next differentiation of p2 by p1 n plus 1 by n is n plus 1 by n into p2 by p1 whole to the power of n plus 1 by n minus 1, that will be equal to 0. Next, further simplifying, 2 by n p2 by p1 means here take LCM n, that becomes 2 minus n, okay, minus n plus 1 by n p2 by p1, again LCM, n is LCM, n plus 1 minus n, so minus n plus n get cancelled, that will be equal to 0. Now taking this term to right hand side, we will get 2 by n into p2 by p1 into 2 minus n by n is equal to n plus 1 by n into p2 by p1 whole to the power of 1 by n. Next, so rearranging this term, 2 by n and taking this to left hand side, this becomes n by n plus 1 plus p2 by p1. So here this, here it is plus 2 minus n by n, here it becomes minus 2 minus n by n, because we are sending this to right hand side, so this index becomes negative. Next, p2 by p1 whole to the power of 1 by n. Next, so this n get cancelled, this becomes 2 by n plus 1 will be equal to p2 by p1 minus 2 plus n divided by n plus 1 by n. So these both are same, so index we have to add. So after adding this index, we will get 2 by n plus 1 is equal to p2 by p1 all to the power of n minus 1 by n. Okay, the final equation is p2 by p1 is equal to 2 by n plus 1. So this becomes reciprocal because we are taking this index to this side, so this becomes n by n minus 1. So this is the equation for critical pressure ratio. If they ask you to derive critical pressure ratio, you need to derive till this point. Okay, here n value varies from this 1.135 to 1.3. So n is equal to 1.135 for dry steam, n is equal to 1.3 for superheated steam, and n equals to 1.035 plus 0.1 into x for wet steam, where x stands for dryness fraction. Okay, next, so if they ask you to find the maximum discharge, what we need to do is we need to substitute equation 7 in 6. We get maximum discharge. We have at 6 we have m, so 7 we have critical pressure ratio. We need to replace wherever, okay, this one. Let me go back. So this is the equation 6. So what we need to do, we need to replace P2 by P1 by equation 7. What is that equation 7? By 2 by n plus 1 all to the power of n by n minus 1. So if you substitute that, you will get the equation like this. Okay. So after simplifying, the maximum discharge is given by A2 square root of n into P1 by V1 into 2 by n plus 1 all to the power of n plus 1 by n minus 1. So this is the equation. If they ask you to derive maximum discharge, what you need to do? Derive till this first, then substitute this 7 in 6, so you will get maximum discharge, this one. Okay, so next they will ask you to find maximum velocity, okay, that is at the exit. So what you need to do, simply substitute equation 7 in equation 4, you will get maximum velocity, that is V2 bar maximum. If you substitute in place of P2 by P1, that is 2 by n plus 1 all to the power of n by n minus 1, and simplifying this, we will get V2 max is equal to root of 2 into n by n plus 1 P1 V1. So this is the equation for to find the maximum velocity. Okay.